Good morning. Good morning. Hope all is well. Hope everyone's doing all right. Hope everyone.
Good morning. No, we're not all right. We have virtual with kids too today.
Sorry to hear that, ma'am. Oh, well, I hope you guys had a great weekend. All right. So let's see. Good morning. Good morning. So we are starting with 3-3 today. All right. So just like I mentioned last class, that's the title, and then I'm going to go to another set of notes. So don't copy this red and green right here. There's notation to myself of what to go to. But the title 3-3 is Summaries for Skewed Distributions. So once again, don't copy this stuff. Just copy Summaries for Skewed Distributions. All right, everybody good? Can we go to the next page? All right, so let's look at the median. All right, so the median is the middle value. So the first step in finding the median is to list your data values from least to greatest. So don't forget that. A lot of people forget that step. Make sure you don't forget that step. You always want to list your data values from least to greatest first before you go into looking to find your middle value. So if the number of your data values is odd, you would take the middle value, because if it's odd, that means you actually have a middle number. But if it's even, you don't really have a middle number. So what you would do is take the average of the two middle values that you have. All right, scrolling up some. So let's look at our first set of data set 1. If we have 1, 2, 3, 4, 5, then we would just take the middle value, which is 3, and that's the mean. All right. Data set 2, if I had 1, 2, 3, 4, 5, 6, since it's an even number of data values, I don't have a legit middle number. So what I would do is take the two middle numbers, which is 3 and 4, add them together and divide by 2. And that'll give me 3.5. And you notice that would be right there in the middle of 3 and 4. So if I'm done with the black, can I scroll up? Oh, that's all I need right there. All right. So green, the median separates the data set into halves. And then you see over here in the orange, it also represents a typical value in the data set. statistically. Anybody still copying? All right, so we're good to go to the next page. Good to go to the next page. All right. So the next thing is our quartiles. So our quartiles divide this data set into fourths. I didn't even mention this right here. So, if you look at this diagram here, your minimum and maximum value will be your bookends. Then we have Q1, Q2, and Q3, quartile 1, quartile 2, and quartile 3. So we only have 3 quartiles. We're done with that first statement. So we're going to list our data values from least to greatest. We want to find our quartiles. That goes back to what we just finished mentioning, because your quartiles are just medians. They're just middle values. So if you look at the second step, we're going to find Q2 first. That's the median of the whole data set, the middle value of the whole data set. Q1 is going to be the median of the first half of data. And then Q3 is the median of the second half of data. So all of them are medians. In other words, all of them are middle values. All right, next thing is the interquartile range. IQR for short. It's the range of the middle 50% of the data. And we will calculate that with Q3 minus Q1. All right, scroll up. Checking for outliers actually comes up in 3.5, but this set of directions and information is better when it's together. So I'm gonna just go ahead and give it to you now. But checking for your outliers. So we talked about outliers before. They're very, very large or very, very small values in reference to your data set. So extreme values, whether it's very large or very small, in reference to your data set. So we're going to establish outliers by creating these fences or limits or boundaries. You know, different books call it different things. I think your book called it limits. But anyway, so it's the same formula though. So if you're talking about your upper fence, Q3 plus 1.5 times your IQR, your lower fence, Q1 minus 1.5 times the IQR. So once we create these numbers, what's going to happen is, anybody hold on to that last little bit up top? Okay, good. So if a data value is greater than the upper fence, then it is an outlier. And then if a data value is less than the lower fence, it is considered an outlier. So it gives us these numbers that are fences or boundaries or limits. Anything's greater than the upper, then it is an outlier. Or if something is less than the lower, it is an outlier. All right, everybody good? And we're still copying purple. Okay. So let's do an example that uses this. I said something copy in green. Okay, cool. I'm gonna erase these circles right here and then give them a chance to get caught up. So in a second, we're going to take this data set down here, find your quartiles, and see if we have any outliers. So we're just taking the information that we just finished doing. Okay, cool. Thank you. All right, so this is our data set. Your first move, your first step is always to list it from least to greatest. There's no guarantee that it will be given to you from least to greatest. And that's a step that a lot of people forget. So make sure you don't forget that. So I already listed the data set from least to greatest. And also notice how I set up my data set. First, what I do is count how many data values I have. I have 18. So I go ahead and write it in half. So I already break it up into 2 halves instead of writing it in a straight line or maybe writing 5 here, 4 here. And, you know, I just go ahead and break it up. 9 data values here, 9 data values here. Now it's up to you. You don't have to do it that way, but you do have to list it from least to greatest. So if you want to write 180 to 21, 147 all in a line, then feel free to do it. But I just think that it's easiest to be able to break up and then find what numbers you need if you already break it into half. Okay. So we have 18 data values. I guess I could read them: 180, 189, 370, 618, 735, 802, 1185, 1414, 1657, 1953, 2332, 2336, 3461, 4668, 6751, 9908, 10,034, 21,147. All right. So next, we're going to find Q2. Now we have 18 data values. We have an even number of data values. So that means we do not have a legit middle number. So what we will do is take the two middle numbers, 1657 and 1953, add them together, divide by 2, and that'll be 1805. So whenever you have an even number of data values, you take the two middle numbers, add them together, and divide by 2.
Mr. T.
Mm-hmm.
Okay, I done confused myself. So you didn't list the numbers by quartiles, like by Q1, Q2, Q3. You listed them like, how you listed them?
From least to greatest, from smallest to largest.
Yeah, going which way? Going horizontal or diagonal?
Oh, this way?
I mean, not diagonal. Okay.
Yeah, and then it connects going this way, and then.
And okay. And that's how you found the two middle numbers.
Uh-huh.
Okay. Thank you.
Yeah, no problem. No problem. All right, everybody good before we go to the next one? All right, so if you notice right here, got my first half of data. Remember, I split it into half. So I had 18 data values altogether. That means I have 9 in the first half, 9 in the second half. So that's an odd number. So there are odd number of data values here. So that means I have a legit middle number, which would be just a 735. So Q1 would be 735. Remember, Q1 is the middle number of your first half of data. Remember, my data set is broken into half, 9 on top, 9 on bottom. The middle number of my first half of data is 735. And then the middle number of my second half of data is the 4668. That will be Q3. All right, everybody good up to step 4? Rolling up. All right, step 5, we can find the IQR now. Subtracting Q3 and Q1. Are they okay? And now that we have an IQR, we can determine our fences, DET, which is short for determine. We can determine our fences or boundaries that will help us to establish whether we have an outlier or not. So the formula for your upper fence, Q3 plus 1.5 times your IQR. And then the lower fence is Q1 minus 1.5 times your IQR. So the upper fence, that'll be 4668 plus 1.5 times 3933. And that will ultimately give us 10,567.5. All right. And then Q1 minus 1.5 times IQR will give us negative 5,164.5. So it's okay to be negative if that's what it ends up being. All right. Any problems with the step 6? And then to finish this off, are there any outliers? The answer would be yes, because 21,147 is greater than 10,567.5. So any number that's greater than this number would be considered an outlier. Any number that's less than this number would be considered an outlier. So you just go back to your data set and do your comparison.
Okay, I have another question, sir.
No problem.
So if it's equal, then it's not an outlier. And that's like the only exception.
Yeah.
Okay.
Yep. That'll be very, very rare that it would be equal. But yeah, if it would be equal, it wouldn't be considered outlier. Yeah. Good question. Good question. All right, are we good, everybody? Okay. All right, so the last thing in this section, I think I already gave it to you, but just in case I didn't. Nope. I gotta be this section. And that is the range. So just right here, the range, I think I already gave it to you, but may not have. Yeah, you also start talking about this. Really might talk about dispersion. Dispersion is okay. So if you see the term dispersion, dispersion is the degree to which the data is spread out. In other words, dispersed. And then your range is the distance spanned by the entire data set. Just take the largest value, subtract the smallest value. So we take our data set of 1, 2, 3, 4, 5, and you want to know the range of your data set. You would do 5 minus 1, which would be 4. All right, anybody still copying? Everybody good, everybody straight? All right. So now we're here at 3.4. All right, so comparing measures of center. I think this is more so, yeah, it's a short section. Just pointed out a few things that they mentioned in the section. So in a symmetric distribution, the mean and median are approximately the same. And we talked about these distributions already, symmetric distribution with that bell-shaped curve. Mhm. In a right skewed distribution, the mean tends to be greater than the median. In a left skewed distribution, the mean tends to be less than the median. Mm, ah. All right. Any questions so far? I'm just trying to do these rough sketches over here, failing miserably. But all right, any problem with the green? I had to shift note pages in a second to go to what it means to be resistant to outliers. But make sure everybody have a chance to copy what's in the green. All right. Anybody still holding on to the green? All right. Gotta be up here. Okay, there we go. So here, talking about being resistant to outliers. A summary of data is said to be resistant if outliers to the data set do not affect it. So I'll show you an example of that in a second. Just give me a chance to write it down. So it's said to be resistant if outliers does not affect it, but outliers do not affect it. All right, so if we have a data set of 1, 2, 3, 4, 5, the mean would be 3. Adding up all your data values, dividing by the number of data values. So that would be 3. And the median would be 3 also. Median is just a middle value. So. But now let's say if I were to replace 5 with an outlier of 500. Now if I find the mean, I add up my data values and divide by the number of data values that I have, that would be 510 over 5, which is 102. But my mean would still be 3. That's still my middle value. And so this means that the median is resistant to outliers. So my median didn't change, even though that number 5 changed to 500. So that means that the median is resistant to outliers. And then that green statement, it is a good choice for a measure of center if the data contains outliers. All right. Anybody still copying?
Yes, I am.
Okay, not a problem. Take your time.
Okay, done.
All right, everybody else good? All right, so black statement is the last statement for 3.4. When comparing groups, if any one group is strongly skewed or has outliers, it's usually best to compare the medians and the IQR for all groups. All right, are we ready to scroll up to 3.5? So using box plots for displaying summaries. It's gonna be the last thing we do in chapter 3. Anybody still copying the title? Using box plots for displaying summaries. All right. So first thing is the 5-number summary, which last section we pretty much found. The minimum value, which is the smallest value, maximum value, largest value. So those two are given in your data set, smallest value and your largest value. And then Q1, Q2, and Q3, the points 2, 3, and 4. All right, scrolling up. Box plots. It's a graphical tool used to compare groups of data. It consists of a box with lines that extend to the minimum and maximum values that are not outliers. These lines are called whiskers. I'll show you an example of that in a second. Just want to make sure everybody done with the purple. All right. Outliers will be replaced or represented by an asterisk. If we have any outliers, that will be represented by an asterisk. So here's a generic representation of what a box plot will look like. You have your 3 vertical lines that make up your box. That's Q1, Q2, and Q3. Then your whiskers, your horizontal lines extending from the box to your minimum and maximum value that are not outliers. If we do have any outliers, whether it be greater than the maximum or less than the minimum, they will be represented by asterisks. And of course, it is possible to have more than one outlier. Each one would just be represented by an asterisk. All right, can I scroll up? Everybody good? All right, so we're gonna pretty much do what we did in the last section. Well, not 3, 4, 3, 3. We're gonna give the 5-number summary though, and then sketch the box plot. So we're gonna do those same steps that we did in 3, 3, and then apply it to the 5-number summary, and then use that to sketch the box plot. So notice that first statement is just a statement of warning or reminder. The data set is not always written from least to greatest, so make sure that this is the case before you move forward. So just keep trying to remind you guys of that, because a lot of times people do forget that first step. All right, so first step is to write a data set from least to greatest. That's what I did here. Once again, I broke up my data set into halves. I have 21 data values. So I did 10, the one in the middle, and then the other 10. So they give me 10 data values in my first half of data, 10 data values in my second half of data. Then I have one that's sitting in the middle. So don't forget Q1, Q2, and Q3 are just middle values. Q2 is the middle value of your first half of data. Q1 is the middle value of the first half of data. Hold on, let me say that. I said it wrong. Q2 is the middle value of the whole set. Q1 is the middle value of the first half of data, and then Q3 is the middle value of the second half of data. Give you guys a chance to write that down. All right. So the first one we want to find is Q2. That's the middle value of the whole set of data. And so, listing it this way allows me to see clearly my middle value is 30.95. So no calculation there needed, just the middle value. Because I had an odd number of data values initially. So that means I do have a middle number. Q1 is the middle value of the first half of data. So now my first half of data has 10 values in it. So I'm not going to have a legit middle number. I need to take the two middle numbers, add them together and divide by 2. And so that's what I did here. 25.83 plus 26.28. Add them together, divide by 2 gives me 26.06. Any problems? Any problems? All right. So do the same thing for Q3. 2 middle values, add them together, divide by 2. So 37.05, 37.43. Divide those by 2 gives me 37.24.
Mr. T.
Mm-hmm.
So Q1, I'm kind of confused because I got Q1 to be the 33.53.
33.5. This value right here?
Yes.
Okay. So now you got to make sure that you're looking at your data set properly. So now this is the whole data set. So it's 21 data values. So Q2 is going to be the middle value of that whole data set, which is this one right here. So now,
I thought it was 2 separate data sets.
Okay, gotcha. Yeah. So do you want? So you want to keep going? You good?
Yes, sir. I got it.
All right, cool. All right. So everybody good? Everybody straight before we go any further? Make sure we're okay going up to step 4. Let's see, good thing about it is when you're doing it yourself, there'll be no confusion. So you'll be all right. So going back to what she just mentioned. So your data set will be just given to you, just I won't say a big blob of number, just a big group of numbers. I broke it up this way just for me and just being able to pick out values easily. Of course, you would just have a whole data set. So I broke it up this way when putting 10 right here, 1 in the middle, and then 10 at the bottom. So just reemphasizing that your data set will not come like this. It'll just be a list of numbers, and you break it up whatever way you like. So, all right. Can we go to step 5? Everybody good? All right, so step 5, find the IQR, Q3 minus Q1. So that'd be 37.24 minus 26.06. That'll give us 1118. Once we find our IQR, now we can establish our fences. You know, here just in this red, just re-emphasizing terminology that it could be the left limit, right limit, and you know, even could be called your boundaries. So it just depends on the book, and but the formula is still the same. Your lower fence Q1 minus 1.5 times the IQR, upper fence Q3 plus 1.5 times your IQR. So our lower fence is going to be 9.29, upper fence 54.01. All right. So if a value is less than the lower fence or greater than the upper fence, it is an outlier. And 54.63 is an outlier because it is greater than the upper fence. So those are all our steps. Make sure we're good before we go to closing it out, doing a 5-number summary and a box plot. All right, scrolling up. There goes our 5-number summary. Now, your summary has nothing to do with if anything's an outlier or not. So whatever's your largest number, whatever's your smallest number, those will be your bookends. So our smallest value is 1995, largest value 54.63, and then Q1, Q2, and Q3 are numbers 2, 3, and 4. All right. Any problems with the 5-number summary? Scroll up. Everybody good? All right, and here's a box plot. So You see in the middle, our box, our vertical lines are Q1, Q2, and Q3 of our box. Then they extend out with the whiskers to the maximum and minimum value that are not outliers. So remember, we had an outlier that was 54.63. So we'll represent that by using an asterisk. So that means we won't extend the whisker to that 54.63. We'll extend it to the next value up, which will be 49.17. Let me just scroll up real quick. So 49.17 is right here. That's the next value up. That's not an outlier. So that's why when it comes to the box plot, 49.17 is where it extends, where the whisker extends. 19.95 was all right. And then here we have our asterisks for our outlier. All right, any questions? Everybody good? All right, so scrolling up, that's it for 3.5. This is it for chapter 3 altogether. So just making sure we're clear on what you guys are responsible for up to this point. So in Math Lab homework, you have chapter 1, 2, and 3. Test 1 is only on chapters 1 and 2, and don't forget those definitions. If you have not sent them to me yet, most of you have. There are a few out there that haven't. So make sure you get those definitions, especially since it's a easy grade. So make sure you get that to me. Chapter 4 is 4.1 through 4.4. My other class is 4.3. And then test 2 is chapter 3 and 4. So you don't have to worry about test 2 as of right now. But these are things that you guys are, are responsible for up to this point. All right, questions, concerns, comments, anything, anybody? Everybody straight, everybody clear? All right, so be careful. Don't let this thing get away from you. Next class, we'll do 4.1.4.2. I don't believe, let me see how much content in there. Not 4.1, might be it's 4.2 that's short, isn't it? Yeah. Hold on 1 second. 4.3. Do we have a 4.4 in this section? Oh, I'm in the wrong. That's right. 155. Sorry about that. Yeah, it should be 4.4. Okay, cool. Yep. Somebody asked a question for definition. We just need email them to. Yep. For definitions, just email them to me. You can take a picture with your phone or a smart device and send it to me. Or if you do it as a Word document, type it up and send it to me. Either way, it's fine. All right, let me go back to, yeah. So 4.1 through 4.4 is what is the next chapter. Yep, no problem. But like I said, be careful. Don't let it get away from you, because next thing you know, we'll be done with chapter 4, and you have 4 chapters out there. So you most definitely want to stay pace and get these things knocked out as soon as you can. All right. So any questions or concerns, comments before we close out today? I know I need to stay back for someone with a personal conversation, but outside of that, any class questions? Everybody good? All right. So if you guys are good, I'm good. You guys have a great day. Be safe, and I will see you on Wednesday. All right. Thanks. Take care.
Thank you.
Thank you. Have a good one.